Okay, our last part of the notes today, we got some exponential decay, taking an amount and having it decrease over time. Now, if you look at this exponential decay formula, it is basically the same with the exception of this minus sign right here. That is literally the only difference. We still have the initial amount going in front. We still have the rate as a decimal going inside the parentheses. And we still have the t for time up in the exponent. So the only thing that's different is when we go to type this into Desmos, we're going to end up putting a 1 minus inside the parentheses instead of a plus. So let's look at a couple examples here. So number one, the price of a car depreciates, meaning once you buy a car, you start driving that car around, its value is going down. Depreciates about 5.2% each year. If you bought a $25,000 car, in 20 years, how much is it going to be worth? So starting to plug this stuff in, starting with our initial amount, that $25,000. Inside the parentheses, 1 minus, we need to convert that rate to a decimal. So 5.2, again, just like we did with growth, thinking about moving that decimal point over twice to the left, turns it into a 0.052. And our exponent, the 20, because we're going to see how much this car is worth in 20 years. Let's get Desmos working here now that we have kind of everything plugged into this formula. So we got the 25,000. That's how much it was worth at the beginning. That's how much we bought it for. 1 minus 0.052, showing that we're losing 5.2%. We're going to hit that exponent button, raise that 20th power. And in 20 years, our $25,000 truck is only worth $8,592.25. Obviously, 247 bumps that 4 up to a 25. So we've lost quite a bit of our value of our car over 20 years as we're driving it around. Okay. Last example, another population example. So we're losing people from this town. This town is, the population is decreasing 3% per year. In 2012, it was 1,700 people. That's going to be our initial amount. And we want to figure out next year in 2026 how many people are going to be left. So the 3%, let's change that to a decimal. Again, thinking about moving that decimal point over, so 3% turns into a 0.03 for our formula. And again, time, we got to do a little thinking. We start in 2012. We're going to 2026. That's a 14-year time span. So our exponent is going to be 14. Let's type it in, 1,700 for our initial amount, 1 minus 0.03, because we're losing 3% of our population. And let's raise that to the 14th power. Okay, now think about it. We are doing population. We are talking about people. We don't want to have a fraction of a person. So we're going to cut this off. Actually, we're going to round it to the whole number. So 9.8 is actually going to round that up to 1,110. So notice, let me zoom out a little bit. For number one, I did use decimals because we were talking about money. Money has decimals because that means we have cents. When we're talking about a population of people, animals, plants, any basic living being, we don't want to have decimals because we don't want to have a fraction of a person. So that's why I rounded that one to the nearest whole number. So just be careful, especially when you're doing your assignment today. Make sure you're rounding appropriately. If we're talking about money, decimals are fine. If we're talking about living creatures, people, animal, plants, whatever, and decimals aren't a reasonable thing, then you don't want to have them. You want to round to the nearest whole number.